Hey guys, good morning. Just wanted to go through the notes real quick. Um, Talking about triangle trigonometry. Really, the main thing of this entire section is being able to solve any type of triangle. And when I say being able to solve, it really means being able to find any of the side lengths or any of the angles of any type of triangle that's really presented to you. Um, that really is the goal here. So the first thing we're going to talk about, sine, cosine, tangent, the relationships between those. That's some stuff that you probably had seen in Algebra 1, probably in geometry as well. But there's a couple of symbols here that I want to make sure that we are aware of. A lot of times they use these symbols to represent angle measures. So the first one, the most common one, theta, and then we have alpha and beta, all just kind of Greek letters. There's another one over here. That one's rarely ever used. I would say 90% of the time we're working with theta, though. And typically that's just the symbol that we use to represent an angle. All right, so the relationship with sine is the opposite leg over the hypotenuse. So if I'm looking at an angle, say I'm looking at angle B, the opposite side or opposite leg to angle B would be this side AC, whatever that length is, over the hypotenuse. So the hypotenuse is always going to be the longest side of your right triangle, and also it's always going to be opposite or across from your 90-degree angle. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is the opposite over the adjacent. You probably have heard like SOHCAHTOA, just an acronym, SOHCAHTOA, just kind of help us to remember the relationships that exist between sine, cosine, and tangent. Talking about the reciprocals of those, and these are three new, probably new trig functions that you guys haven't really worked with a whole lot, and that is cosecant. Let me scroll back up again. Cosecant, secant, and cotangent. There's our abbreviations for them. So we just have to remember cosecant is the reciprocal of sine. So reciprocal just means whatever the ratio of is sine, if you flip it, that represents cosecant. So if sine is opposite over hypotenuse, cosecant is going to be the hypotenuse over the opposite side. Secant is the reciprocal of cosine. So if cosine is the adjacent over hypotenuse, then secant is going to be the hypotenuse over the adjacent. And cotangent is the reciprocal of tangent. So if tangent is opposite over adjacent, cotangent is going to be adjacent over the opposite side. And we can really use those to solve right triangles. If I know a side length and an angle measure, I'm going to be able to solve and figure out the rest of the sides and angles of your right triangle. Just keep in mind another special property that exists with right triangles. Pythagorean's theorem, a squared plus b squared equals c squared. That's another great tool to use when you're trying to solve right triangles. These two right here are kind of special right triangles, and I'll get into more of this on the next page. The first one's kind of just talking about a 45-45 90 right triangle, and the other one's a 30-60 90 right triangle. Obviously, in a 45-45 90 right triangle, since the two angle measures are both 45, those side lengths that are across from them are going to be equal to each other. If the angles are equal to each other, then the side lengths across from them are going to be equal to each other. So moving down here, just kind of talk about the relationships and how you can use this. If I know that I'm working with a 45-45 90 right triangle, there are two things that are really important. Number one, the two legs of the triangle are congruent. That's important to know. The angle measures that are across from them are equal to each other. They're both 45, so the side lengths across from them are going to be equal to each other as well. And the other one is going to be the hypotenuse is whatever the length of one of your legs is multiplied by the square root of 2 gives you that hypotenuse. So if I know that one of my legs in a 45-45 90 right triangle is 10, I can find the hypotenuse by just taking 10 and multiplying it by square root of 2, and there's my hypotenuse. The same thing could be true if I knew the hypotenuse and I'm trying to find one of my legs, I would just take my hypotenuse, whatever it is, and divide it by square root of 2. And now I know both my leg measures. In the 30, 60, 90 right triangle, the 30, 60, 90 right triangle, there's two special relationships that exist. The longer leg is square root of 3 times the shorter leg. And the second one would be the hypotenuse is 2 times the shorter leg. So those two are nice. And really, you can still use trig functions to be able to solve and find out the side lengths and hypotenuse if you wanted to, or Pythagorean theorem if you knew two sides. This is kind of just the fact that those two triangles are special, and there's special relationships that exist. The only thing we would be using those for is being able to find out the lengths of sides faster than if I was actually using just normal trig. There's two examples here, and I'm not going to talk a whole lot about them. I mean, you guys can read through these. This is stuff that you guys have done in the past. This is basically just talking about to solve a triangle, you have to find all of the missing sides and missing angles, and they are just kind of working through this and doing that. The only thing that I would say that's important, and it's a calculator issue, is your calculator needs to be in the mode of degrees and not radians. There are multiple ways to measure an angle. We're going to get into that here probably next week. But radians is one of those ways. And if I'm typically just working with solving a triangle, I want to be in degrees and not radians. So if you're using a TI-83, you just hit the mode button, and one of those options is degrees or radians, and you just need to make sure degrees is highlighted. And then you can go back and actually and solve for that. So I'm going to scroll down here. The area of an oblique triangle, I'm going to kind of skim over this and move past this. This isn't something that's really important. There's two things that are left here that are extremely important. So if I have a right triangle, I can use just normal trig, maybe an inverse trig to find the angle measure, but normal trig to find out the side lengths. But when I move past a right triangle and I look at an oblique triangle, so up here it kind of gives you the definition of an oblique triangle. It doesn't, but an oblique triangle is basically any triangle that is not a right triangle that has an oblique angle, which means greater than 90 degrees. So there are two different laws that we can use to solve any type of triangle that's not a right triangle. Law of sines and law of cosines. Law of sines is probably the easiest to use. If you look there, it says sine of angle A over side angle of A is equal to sine of angle B over side B, which is equal to sine of angle C over C. So if I was just talking about this and I said, all right, here is a right, or just not a right triangle. Here is a triangle. If I know 3 parts of that triangle, I should be able to solve for a 4th part. Okay, so let's just say I know this angle is A, and I know the side across from it. And if I know one other point, and it doesn't matter what it is. So at this point, this is the most important thing. If you're going to use the law of sines, you have to know an angle and the side across from that. If you know that, you're going to be able to use the law of sines because you're going to be able to set up that and have the beginning part of a proportion. If you have one other thing that's known of that triangle, you're going to be able to solve the part that's kind of related to it. So let's just say I know this angle, say C. I could solve for that side using law of sines. And the way that I would set it up is I would have sine of my angle of A, which I know, over my side length of A, because that's the one where I knew the angle and the side across from it. And I would set it up as sine of angle C, which I know, over that side length of C. So that's what I would be able to solve for, is that side length. And at that point, if I'm solving a triangle, if you know two angles of a triangle, you can find the third by just subtracting the two angles that you know from 180, and then you know the third, and then you can kind of go from there to find out the last side. But that law of sines that's written up there, I can basically separate that out however I want to. Maybe it's sine of A over A is equal to sine of B over B. Maybe it's sine of B over B is equal to sine of C over C. Or the third option would be sine of A over A is equal to sine of C over C. It just kind of depends. But the most important thing is you have to know an angle and the side across from it to be able to use law of sines. Then after that, once you actually start working with a little bit more, that one becomes pretty simple. So the other one that we are going to talk about it, and this is just talking a little bit more about law of sines. This is what I just said, but what combinations of information within a triangle would not allow you to use the law of sines? Like if you knew all three sides, you couldn't use law of sines because I don't know an angle and the side across from it, because all I know is the sides. Side, angle, side. Okay, what that would look like, side, angle, side. I know a side, an angle, and a side. So do you know an angle and the side across from it? So in this case, I do not know that side. So I would not be able to use law of sines if that was presented to us, side, angle, side. The other one would be angle, angle, angle. Obviously, I could not use law of sines if I had angle, angle, angle presented to us, because I do not know the angle and the side across from us. Got my little math mug going on here today. Notice that there's some logarithms in there. All right, so the other one is law of cosines. So as you can see here, law of cosines is definitely a little bit more involved when you are looking at the formulas. And those are just three different ways that you could use a formula. So you have a squared is equal to b squared plus c squared minus 2bc times cosine of a, or the other two options that are listed there as well. So if we are using law of cosines, really the thing that's important is you really want to have just one unknown out of all of this, out of this one entire formula. So like maybe you don't know side A, but you know side B, side C, and then angle A. In that case, you could use law of cosine. So if I were going to just have a triangle that would look like that, here's angle A. Let's say this is B. There's C. So the sides across from that, say I don't know what angle A is, or side A, but I know side B, and I know angle A, and I know side C. I mean, that's our side, angle, side that we're talking about. So this is what we're going to have to use if we have side, angle, side that's presented to us to be able to solve for an angle, or solve for our missing side. And then once you know that, and really law of cosines, you're really only going to have to use that once. And then once you use it once, then you are going to know more than likely the angle and the side across from it. And then you can just go back to using law of sines. Like in this case right here, if I was solving for A, once I actually find out what this side is, I would know that side and the angle across from it. Now I can go back and start using law of sines to figure out all of the other stuff. Or maybe I know all three sides. If I know all three sides already of our triangle, then I could use really any one of those formulas. They could really use any one of those formulas to find out one of your angles. Say you want to use the first one, a squared is equal to b squared plus c squared minus 2bc times cosine of a. You could plug in all of those side lengths and solve for angle A. And if you did that, then you would know the angle and the side across from it, and you'd be able to go from there to find out all of your other missing sides. So they walk through a couple of examples there in terms of solving an oblique triangle. I think all of those, they use the law of cosines once, and then they kind of just go from there to figure out the rest of the sides. But this is all you guys had for the week. There's really just 2 days of homework that was working with this. That's due by Friday by the end of the day, or I guess really Sunday. It doesn't really matter as long as I have them before next Monday. And it sounds like we're getting a little bit more information coming out about the rest of the school year for us and what that's going to look like. It sounds like for students now, May 13th is going to be really the last day that teachers are going to be assigning or could be assigning new work. And then students have all the way up to, I think it's May 22nd to complete assignments. And then that's basically it for you guys for the year. There's also been talks of there's going to be some type of an assignment that has to be done by students in between May 14th and May 22nd. But I think that's going to be, it sounds like maybe like some type of completion assignment that maybe could boost a grade, or there's some type of incentive with that. We're still learning more information about that, and we'll probably have that for you here soon. But hope you guys are doing well. But that's the notes for today. I'll probably post some more stuff on Monday. I'll post some stuff on Monday that really has our work kind of Monday through really probably Friday of next week. I might actually go Monday of next week, since that's May 4th. May the 4th be with you. And then kind of go from May 4th all the way to our last kind of day where we could be assigning new work. And then you guys would have till some point in time to turn everything in. So hope you guys are doing well, and make sure you're emailing me and getting a hold of me if you guys have questions.